Next is instrumental axis at different level. In that first case, when the instrument B is higher than A. See, this is the figure. Observe in this figure. Here the instrument A is lower compared to that instrument B. That is, instrument B is higher than A. That is, instrument B is higher compared to the instrument A point. Okay. See, this is the figure. This is the ground point. Okay. This will be the instrument at the A station, and this will be the instrument at the B station. The instrument at the B station is higher compared to instrument at the A station. Distance between the instrument A and B, it is denoted by B, and the distance from instrument station, that is the first station, to that elevated object, it is denoted by D value. Okay. Similarly, S1 is the staff reading taken on the benchmark when the instrument is at station A. Similarly, S2 is the staff reading taken on the benchmark when the instrument is at B point. A dash and B dash are the instrumental axis or when the instrument is at station A as well as B point. Okay. Next, H1 is the height of the elevated object. H1 is the height of the elevated object from the instrumental axis, that is A dash, to that Q point. H2 is the height of the elevated object, that is Q, from the instrumental axis B dash to that Q point. Okay. Next, first, in order to derive that, what you need to do is you need to set up the instrument station over A. You need to do all the temporary adjustments, and you need to set vertical circle C reading to 0. Then you need to lose that vertical clamp screw, and you need to bisect an elevated object. Then the first reading which is going to take it, that is alpha 1. That will be the vertical angle when the instrument is at A point. Next is you need to shift the instrument to the B point. Then bisect an object Q and take down that vertical angle reading, that is given by alpha 2. Okay, initial data you need to consider it is alpha 1 as well as alpha 2. In this case also you need to calculate H1 and H2 value as well as D value. In order to derive that, okay, the same procedure, consider a triangle, call this point as Q dash and this point as Q double dash. Okay, from triangle, that is from when the instrument is at A point, okay, consider a triangle, that is A dash Q, A dash Q, Q dash. Okay, apply the tan function, that is tan alpha 1 will be equal to tan theta equals to opposite side, it will be H1 divided by distance from, that is A dash Q dash, will be equal to D value. Cross multiply that, H1 equals to D tan alpha 1. Call this as equation 1. Similarly, when the instrument at the B point, apply the tan function, that is from triangle, that is B dash Q, Q double dash, that is B dash Q, Q double dash. Okay, apply that as tan function, tan alpha 2 will be equal to opposite side, it will be H2 divided by, that is B dash Q double dash, distance it will be B plus D value, that is B plus D value. Cross multiply that, H2 will be equal to B plus D into tan alpha 2. Call this as equation 2. Okay. Next it is you need to subtract, that is which is higher value. Observe in this figure, this is H1 and H2 are the height, that is height of an elevated object from the instrumental axis A dash as well as B dash. Observe here which is greater here, H1 is greater than H2. Then subtract equation 1 from 2. Okay, that is subtracting equation 2 by 1. Okay, then it will be, you need to subtract the equation 2 from this equation 1. Then it will be H1 minus H2, that will be equal to, what is H1 equation, that is D tan alpha 1, right, minus H2 will be B plus D into tan alpha 2. This is the equation. Okay, next simplify this equation, that is RHS side, simplify that. Tan alpha 1 will be that is minus, take tan alpha 2 inside that bracket, okay, that is b tan alpha 2 plus into minus, it is minus b, sorry, that is d, right, this is d tan alpha 2, right? Okay, from these two term, d is the common term, take it that d into tan alpha 1 minus tan alpha 2, okay, minus of b tan alpha 2, that will be equal to h1 minus of h2. Okay, what is that is h1 minus h2? It is nothing but, okay, difference in levels, right? Difference in levels of instrument, difference in levels of instrument axis, okay, that is instrumental axis. H1 and H2, it is nothing but difference in levels of instrumental axis. Difference in levels of instrumental axis means what? S2 minus of S1, which is higher one. Okay, H1 and H2, it is nothing but that will be equal to difference in level of two instrumental axis. That will be equal to H1 minus H2 will be equal to, which is higher value, difference in level, that is S2 minus of S1. That will be equal to, that is the staff reading, it is denoted by capital S. Okay, then substitute this in that equation, that is H1 minus H2 will be S, that will be equal to D into tan alpha 1 minus tan alpha 2, okay, minus B into tan alpha 2. What do you want in this equation? You want D value, okay, bring this term, that is bring B tan alpha to the RHS side, okay, that will be equal to, D will be equal to B tan alpha 2, bring this side, plus S divided by, this will be in the denominator, that will be tan alpha 1 minus of tan alpha 2. This is the equation to calculate the distance of an elevated object from the instrument station. Okay, that is d tan alpha 2 plus S divided by tan alpha 1 minus tan alpha 2. Substitute this D value in any one of the two equation. You will get it H1 as well as H2 value. Okay, substitute this D value. Okay, once you substitute this D value, you will get it H1 as well as H2 value. Okay, substitute it and you can calculate it. Okay, next is, in order to calculate the RL of elevated object Q, it is given by, that is RL of Q equals to, you will be knowing this will be the benchmark, you will be knowing the RL of the benchmark, that will be equal to, if you consider, if you are going to calculate the RL of an elevated object from the instrument station A, the equation is given by, that is RL of benchmark from the instrument station A. Okay, RL of benchmark, what will be the staff reading taken when the instrument it is at A point, it is S1, right? RL of benchmark plus S1, right, plus S1 plus H1. H1 is what? H1 is nothing but D tan alpha 1. D is what? Substitute the D value in this equation, that is B tan alpha 2 plus S. S is what? Difference of the two staff reading, which is higher value, you subtract it. What the value you will get it, that is S value divided by tan alpha 1 minus tan alpha 2. Okay, this is when it is at, this is the equation to calculate, that is the RL of Q when the instrument is at A point. Similarly, the RL of Q when the instrument it is at B point, that is RL of benchmark. RL of benchmark, the staff reading taken when the instrument at B point, it is S2 plus S2 plus, what will be the height? It is H2. This is the formula to calculate the RL. Okay, this is at A station. When the instrument it is at A station, this is the formula to calculate RL. This is when the instrument at B. At B station, this is the formula to calculate RL.